Welcome. In this general chemistry tutorial, we'll look at balancing a redox reaction by change in oxidation number. Here we have the following reaction. We want to balance it in acid by the oxidation number method. Our first step is to identify the oxidation numbers of the redox atoms. Any cation will have the same oxidation number as its charge. So the manganese has an oxidation number of +2. For BiO3-, the sum of the oxidation numbers has to add up to the charge. Oxygen has a -2 oxidation number, so that's -6, which makes bismuth +5. Similarly, the oxygens in MnO4- would be -8. Manganese will be +7. Bismuth has a +3 oxidation number. Now we want to balance the redox atoms. On each side of the equation, we have one manganese as well as one bismuth. So our redox atoms are balanced. Let's label the reduction and oxidation electron changes. For the manganese, we increase in charge from +2 to +7. So it goes up by 5. That would be oxidation. Our charge increases. Bismuth goes from +5 to +3. That decreases by 2. That's reduction. We need the same number of electrons being exchanged. So the least common multiple between 5 and 2 is going to be 10, which means to the manganese series, we'll multiply by 2. So 2 Mn2+ and 2 MnO4-. To the bismuth series, we'll multiply by 5. This balances the total number of electrons exchanged. Now we want to balance the total charge. Since it's in acid, we'll add H+. The total charge on the reactant side is -1. We have +4 and -5. On the product side, the total charge is +13. That comes from 2- and +15. So we'll add the hydrogen ion to the reactant side. We'll add 14H+. Our last step is to balance the remaining atoms. We need to just balance with water. We add 7 water. If we were to balance this reaction in base, we'd get to step 4, balancing the total number of electrons. And then now we want to balance the charge by adding hydroxide. So again, the total charge on each side is -1 and +13. So this time we're going to add the hydroxide to the product side. That would match the total charge of -1 on the reactant side. Our last step again is to add water. We add 7 water to the reactant side.